Hey, Anna, I keep hearing more and more about quantum computing, but lately it's been linked with green tech. Like, what's really happening there? Is it still just lab stuff, or is it actually making a difference?
Oh, Alex, it's absolutely moving beyond the lab. We're seeing nations and industries actively piloting these hybrid quantum classical systems. It's not just theoretical anymore. The main idea is tackling huge energy challenges, right? Like, for example, two big areas are grid and infrastructure optimization, so balancing loads, predicting outages, integrating renewables. And then the other huge one is material simulation, which is super exciting. Think next-gen EV batteries, hydrogen fuel cells, even new solar materials, all being modeled at atomic scales to make them way more efficient. It's a real game changer.
Wow, so it's really getting practical. Not just theoretical what if, but like, here's what we're doing now. That's fascinating. So, beyond just the big grid and battery stuff, are there other areas in green energy where quantum is starting to, quietly make an impact?
Oh, totally. Absolutely. Quantum's quietly transforming a bunch of other sectors too. Take hydropower, for instance. Canada's working on simulating dam operations under climate uncertainty, and Norway, Switzerland, they're piloting quantum-inspired optimization for predictive maintenance of reservoirs. Then there's geothermal. Germany's Fraunhofer institutes are modeling thermal conductivity, and Iceland simulating geothermal rock behavior. And wind energy? Denmark's developing quantum-enhanced turbulence simulators for offshore installations, and the UK, India are optimizing wind farm siting. Even solar energy, we're seeing Portugal pioneering quantum-enhanced forecasting, and China, South Korea simulating advanced materials for more efficient panels. It's pretty wild how diverse the applications are, honestly.
That's incredible. So it's not just one like silver bullet, but it's really tailoring solutions across the entire energy spectrum. Do you know what I mean? Okay, so we've got all these incredible applications. What would you say are the biggest like concrete opportunities that quantum computing is opening up for green tech right now? What's really going to move the needle?
That's a great question, Alex. Honestly, the potential is it's huge. First, there's energy optimization at scale. Quantum algorithms are perfectly suited for things like grid load balancing, real-time market design, and integrating renewables efficiently. Our current systems, they really struggle with those complex combinatorial problems. Second, and this is super exciting to me, are the breakthroughs in battery and hydrogen materials. Quantum chemistry lets us simulate new materials for solid-state batteries, long-duration storage, and clean hydrogen production. Stuff classical approaches just can't handle at an atomic level. And third, enhanced climate forecasting. Hybrid quantum AI models are improving short-term weather and renewable output prediction, which is crucial for, avoiding energy shortfalls as renewables scale. It's all about making our energy systems smarter and more resilient, really.
Wow. So it's not just about like more energy, but smarter energy. Which of those do you think is going to have the most immediate impact?
It's a tough call, Alex. They're all so vital. But if I had to pick one for immediate impact, maybe the materials breakthroughs for batteries and hydrogen, because energy storage is such a bottleneck? But we do face hurdles. Hardware limitations are a big one. Low qubit counts and high error rates mean it's still mostly proofs of concept. Then there's a real talent shortage. We need pros who get both quantum and energy. Integrating with legacy infrastructure is also a huge, complex challenge. However, the outlook for 2026 is genuinely positive. Quantum isn't seen as a distant miracle anymore. It's becoming this specialized tool embedded in energy infrastructure conversations. Nations are either building fully integrated quantum green stocks, like the US, or adopting cloud-first strategies for faster, more affordable adoption, like India. We're definitely moving from experimental to essential, really.
So the challenges are real, but the path forward, it sounds like, is pretty well defined. even with like different approaches. Thanks, Anna. This has been incredibly insightful.